Hey guys, good evening. So today we want to discuss about alkynes. So alkynes are also hydrocarbons. So these are hydrocarbons that contain a carbon-carbon triple bond. Carbon-carbon triple bond. Are we together? Then we have the general formula. It is CnH2n-2. Then we have the functional group, and that is C, the triple bond, then hydrogen on the other sides. Nomenclature, the same rule that we used in alkynes, alkenes are the same rule that we are going to use in alkynes. For that case, I will not explain on the nomenclature of alkynes. Isomerism, we have two types of isomerism. We have branching isomerism and positional isomerism. So we start with branching isomerism. This is now a type of isomerism that only affects the position of the branch or the substituent. The position of the branch is shifted or is amended. Branching isomerism. For example, when I have a compound like this one, then I have a branch at this particular point here. This compound is, so instead of naming at this particular point, this compound is 4-methylpentane. 4-methylpentane. So that is now one of the isomer of this compound. The second isomer of this compound here. So I will now put here the branch at that particular point for that case. Then so this one is 3-methylpentane. You can see I have just played with the position of the branch. Hii imekuwa hapa, it can move at carbon number 3. So it is only playing with the position of the branch. We have another type of branching known as positional isomerism. Positional isomerism. So this one is now playing with the triple bond only. The triple bond shift from one side to another, from this carbon to this carbon, from this carbon to this carbon. For example, I have a compound like this one here. I have a compound like this one, the one I want to draw on the board. This is now the compound. This is my compound. This one is my compound. This one is my compound. So this compound is called pentane or pent-2-wine. So I can also remove this triple bond and place on carbon number 1, or on carbon number 3, or on carbon number also 1. So when I place this one on carbon number 1, this compound here will be pentane. So I have a triple bond at that particular point. Then of course you have hydrogen. So this one is pentane. So these are, or you can talk of pent-1-wine. So these are the two isomers of this compound. Even if you have a branch at this particular point, even if you have branches on the same, the branches will just remain to where they are located on the carbon that is located. Don't interfere with where the branch is located. As long as they say give the positional isomer of that compound. Even if you have a branch, don't interfere with the branch. And if they have, they say give the branching isomer of that particular compound, don't play with the triple bond. That's the triple bond should remain intact where it is placed, and just play with the branch only. I hope I'm communicating clear. So they can, but if they don't specify, if it is positional or branching isomer, you can just use, or you can just give any isomer. You can just play with the branch, you can just play with the position of the triple bond, as long as they don't specify. But if they specify, just know what to do. So let's move quickly on preparations of alkynes. Preparations of alkynes. How alkynes are prepared. Preparations of alkynes. And this is a very simple thing. A very simple thing that you need just to know by yourself. Let me draw this one. You can just pause as I draw. So guys, this is how we can prepare alkynes. Like for example, I'm using a simple alkyne known as ethyne. Ethyne. So ethyne, we have what we call calcium carbide and sand. Then of course we have heat. We have sand, calcium carbide. Then it is now prepared by the method over water. So we are saying that place sand into a flat bottomed flask enough to cover the base. Then place small amount of calcium carbide on the sand. Add water from the dropping funnel. So we are adding water from the dropping funnel, dropwise until a steady flow of the gas is obtained. Collect the gas in the several tubes and carry out the tests. So calcium carbide reacts with water at room temperature to form ethyne and calcium hydroxide. So when this calcium carbide water is added into it, it will react with water to form ethyne and also calcium hydroxide. That is the first equation. The first question that you'll be asked at that particular point. You write the equation that's taking place in the flat bottom flask. This is the apparatus called flat bottom flask. This is the dropping funnel. Also take note of this apparatus. So the equation here, it is calcium carbide reacting with water. Then it forms ethyne, which is C2H2, then plus calcium hydroxide, plus calcium hydroxide. Ensure that the equation is balanced, and then the state symbols must be there also. State symbols are very important for your case. So calcium carbide is solid. This one is solid. Calcium carbide is solid. This one is liquid. Ethyne is a gas. Then this one you see in aqueous. So that is the first equation or first question. So when you add water into the calcium carbide, so the gas will be produced, and since the gas is also less dense than air, it will be moving up there. Then it will now be collected by the method of over water method, because it's also slightly soluble in water. So we normally have so a layer of sand is placed at the base of the flask because the reaction is highly exothermic, and the sand will absorb the excess heat and therefore prevent the flask from breaking. So the importance of this sand being placed at the bottom of the flask is because the reaction between calcium carbide and water, it is highly exothermic. Exothermic means it produces a lot of heat, and when the heat is excess, this round flat bottom flask can break, and therefore sand will absorb that heat, and therefore the flask will not break. So the sand here is to absorb the excess heat that is produced by the reaction. So this reaction is highly exothermic. It means that there is production of a lot of heat. So that is it. That is how ethyne is prepared. Also propane can be prepared the same way. Propane can also be prepared the same way using so alkynes are now prepared the same way, calcium carbide and water. So we can move to physical properties of this ethyne. And the first physical properties, which is obvious, alkynes are gases. They are gases. They are gases. Odorless and colorless. Physical properties. Physical properties. Though this one is not common, but you can be asked. So number one, colorless, odorless. Then you can also talk of also it has a pleasant smell. Then it is collected by water, and therefore it is likely soluble in water. Then alkynes of higher molecular formula, they require higher boiling point and melting point because of the bond between the carbon and carbon atoms. Between the bonds of carbon and carbon atoms. Also, the solubility of these alkynes increases as the number of the number of the chain also increases, and the reason is the same, because the molecular formula as the chain increases, it increases the molecular formula, and therefore the forces between the atoms also increases. Let's move to chemical properties. The first one is combustion reaction. Combustion reaction. Combustion is just burning in air. Combustion reaction. Combustion, that's burning in oxygen. Air contains oxygen. So when you burn ethane, in air, obviously it will produce carbon dioxide and water. EH2 then plus oxygen, it produces carbon dioxide plus water. And this one, it is when it is in excess supply of oxygen. But in limited supply of oxygen, ethane will burn in limited supply of oxygen to produce carbon dioxide and water. So take note of that. They can write for you an equation, then they place here limited supply of oxygen. Ensure this particular point is for carbon dioxide. But if it's excess, or if they just say combustion reaction, ensure that it's carbon dioxide and water. Then we also have then also the equation must be balanced. Here you have 2, 5, 4. 2, 5. We have 2, 5, 4, 2, 5, 4, then 2. Of course, this one is a liquid gas. Gas, then here is also a gas. Then addition reaction. So this addition reaction I will not explain much because I explained in alkenes.
Use that position stand.
Or at this particular point.
Yes.
So I will not explain this addition reaction, because addition reaction, that's addition of hydrogen. So when you add hydrogen to that compound, so let me elaborate a bit. So like for example, I have a compound like this one. I have a compound of alkene at that particular point. Of course, this one is hydrogen, this one is hydrogen. Then addition reaction, it means that you are just adding hydrogen to that compound. So when I add one molecule of hydrogen, it will break one bond at that particular point. Then it adds that bond. This hydrogen will now be attached at that particular bond. So when I add this one, it will be double bond now. Then those hydrogen are attached at that particular at this particular point. So that is what we call addition reaction. One bond will now replace the two hydrogens. Also, this alkene will be broken further to alkane, and this bond will not be there. So this alkene will be broken further to an alkane. When you add that one, will be now an alkane, and that one is ethane. So that is now a complete reaction of addition reaction. That is what they normally ask there. Then in this addition reaction, we normally have a catalyst. The catalyst is nickel catalyst. Nickel catalyst at a temperature of 200 degrees Celsius. So this one is nickel catalyst. Nickel catalyst at a temperature of 200 degrees Celsius. So the two conditions must be met for this reaction to take place. Nickel catalyst and a temperature of 200 degrees Celsius for this reaction to take place. And these are the two questions that are normally asked at that particular point. Then also we have reaction with the hydrogenation. Hydrogenation, that means addition of hydrogen. Also reaction with halogens. Like for example, I replace this particular point with bromine. This hydrogen, I replace it with bromine. I also replace this one with bromine. The same reaction will take place. That bromine molecule will break one bond here, then it forms a double bond. Then the one bromine will be formed on the first carbon, another on the second carbon. Also, when I use the same bromine, it will break the bond here. It forms a single bond. One bromine on the first carbon, another bromine on the second carbon. When I use chlorine and also chlorine, the same reaction will take place. That's what we call halogenation, and it is also a part of addition reaction. And also we have hydrohalogenation. Hydrohalogenation, this one is also simple. Hydrohalogenation, I have a double bond at this particular triple bond. Then this one is hydrogen bromide. Hydrohalogen, it means there's a combination of hydrogen and bromine, or a halogen, any halogen. So also this molecule here, or this compound here, will break a bond here, then it forms a double bond. The product will be an alkene. And this one, you can place bromine on the first carbon and second carbon. It doesn't matter. When you continue with chemistry, you will learn a rule known as Markovnikov's rule, which it will guide you where to place the hydrogen or the bromine. But for your case, that is how you place those things there. Also, so those are now the reactions of alkenes. And these alkenes, the reactions of alkenes and alkenes and alkynes are the same. They are unsaturated because these triple bonds need another carbon or another atom for it to be stable. So it is unstable, and therefore the physical test, when you take a burning splint, then you burn this one on a burning. When you burn this one on a spatula, it will burn with a yellow sooty flame, so that it is an alkyne. And also, that is it. So we have test for alkynes. The test for alkynes is similar to the test of alkenes that one I have said, in which the oxidizing agent is decolorized. However, the reaction is faster for alkynes than alkenes. Then uses of alkynes, they are used in the industrial manufacture of compounds such as adhesives and plastics. So alkynes, so the uses of alkynes are the same as the uses of alkenes. Manufacture of plastics. Then in the manufacture of synthetic fiber such as rayon, it is a synthetic fiber. Then the production of important chemical reagents and solvents in which they are used in starting material. So for the uses of alkynes, you can just read for yourself because they are just simple as the one in alkenes. Thank you for watching, and that's the end of organic chemistry. So ensure that you do practice in this organic chemistry for you to get well versed with it. Thank you.